Let's look at some code. Okay. So let's just do simple client. So simple client, all it does is connects to a socket and writes something and reads it. So here's the entire thing. I create my IO manager with no arguments. The default is to do a hijacking scheduler with one thread. So that means that all of a sudden this thread has a scheduler controlling it. I can do an address lookup for the first argument, and this actually has an optional parameter for a scheduler because the native getAttr_info does not support non-blocking behavior. So it has an optional argument for a scheduler to switch to that scheduler and yield on this thread. I don't use that here because I didn't feel like. I create a socket associating it with the IO manager. So, I could do it without the IO manager, which means it would block. But I want to do asynchronous IO. So I create a socket compatible with that address. I connect to that address. And that connect will not block. It cooperates, which means that when it says I'm not going to connect immediately, it yields to the scheduler, which has no other fibers scheduled on it because obviously we're not doing anything else. And so it just sits there and idles and waits for the event. Send and receive are the same. Print out what we want, shut down the socket gracefully, and return. That is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code. Create a socket, connect, receive, full error handling, boost current exception diagnostic information, gets all the details of where it came from. So let's look at doing something in parallel, all in the same thread. Echo server. So echo server, I create my IO manager, and then I call start socket server, which is up here. Looks up localhost port 8000 and creates a socket compatible with it with the IO manager, binds to that address, and then starts a new fiber for the socket server. This fiber listens and, while true, accepts, so we get our new socket, create a stream for it, and schedule a new fiber just for this connection. So this would look like your normal threaded server where you spawn a new thread for each connection. Instead of spawning a new thread, we're spawning a new fiber because we only have one thread. And stream connection just takes a stream and transfers the stream to itself. Reads from itself and writes exactly what it got. Writes it back to itself. Waits for EOF and closes the stream when it's done. Let's actually run this one. So I'm going to pause it to show that I have exactly one thread. And we'll see if I have. Okay, let's connect to localhost port 8000. Uh-oh. Of course. So how come it didn't? Demos have to fail.
Very well.
I don't know.
It's there.
It's there.
You need to use the iTunes.
Yeah. If I can type. Tell them I one port 8000. There we go. And telnet sucks and doesn't print things correctly. But I'm going to show that. I'm going to start another one. Telnet to port 8000. Another connection.
And it's
So both of these connections are running and responding in a single thread. Okay, I think that about wraps it up. We'll have some other presentations that go into what else is built on top of the fibers in Mordor. We've got streams, we've got a really cool HTTP client and server. So thank you for your time.